Welcome to session 7, in which we discuss Ethernet technologies. Like we've said before, Ethernet is the most widely used technology today. In this session, we discuss how Ethernet operates. We know that it will operate at the link layer and at the physical layer. And we know that it's a family of networking technologies which is defined in the 802.2 and 802.3 standards. At the end of the session, you should be able to compare and contrast 10-base-5, 10-base-2, 10-base-T Ethernet technologies. You should be able to describe the key characteristics and varieties of 100 megabits per second Ethernet, describe the evolution of Ethernet, compare and contrast Gigabit and 10 gigabit Ethernet. The key topics to be covered are the 10 megabits and the 100 megabits, the 1000 megabits and the gigabit Ethernet. The reading list is shown. Now that you know about standard bodies that which are involved and what they've done, it is time to look at the various standards a bit in detail. I'll show you a table in the next few slides, and that sort of compares things for you. First of all, there's some guide in Ethernet coding. We've said this in previous sessions, but sort of bringing them all together here. 10 at the beginning means the network operates at 10 megabits per second. Base means that the type of signaling used, in this case baseband. 5 or a 2 at the end indicates the maximum cable length in meters. T stands for twisted pair cable. X means full duplex. And FL at the end stands for fiber optic cable. Now, if you look at this table, what you see, it sort of compares the various types of Ethernet technologies. So 10-base-5, which is a thick coaxial, the maximum bandwidth is 10 megabits per second. The maximum length is 100 meters. The physical topology is a bus, and the logical topology is also a bus. So this way you can sort of compare and see what the various are. So if I gave you, say, 1000-base-T and tell you to interpret it, then you should be able to tell me that, oh, it's 100 megabits per second. It uses a twisted pair, or still a twisted pair, and that is star or bus, and that uses a category 5 UTP cable. Right. The 10-base-5, 10-base-2, and 10-base-T are considered to be what? Legacy Ethernet. They were the original forms of Ethernet that were used. The 4 common features of legacy Ethernet are the timing parameters, frame format, transmission process, and a basic design rule. The diagram shows you which technologies operate at what layers. So you can see that these are at both the physical signaling layer and the physical medium. And this is for the logical link control sublayer. 10-base-5 systems represent a single point of failure. They use a Manchester encoding system. Each of the maximum 5 segments of the thick coax may be up to 500 meters long. That's what the star 5 stands for. The cable is quite large and heavy, and because of it makes it very difficult to install. 10-base-2 also uses Manchester encoding. Only one station can transmit at a time, otherwise a collision will occur. It uses half duplex. The maximum transmission rate is 10 megabits per second. There may be up to 30 stations on any individual 10-base-2 segment. Now, what about 10-base-T? It also uses Manchester encoding. Now, we've been talking about Manchester encoding. I've mentioned it several times, but what is it? How does this encoding work? 10-base is cheaper and easier to install than the category 3 and shielded pair. It's half duplex, or can be also full duplex configuration. That's the choice is yours. 10-base-T carries also 10 megabits of traffic in half duplex mode, and so in full duplex, that is 20 megabits per second. what's the architecture for 10BASE-T wiring? The links generally consist of a connection between the station and a hub switch. So there is a link, you use them to connect the stations with the switches, as you can see in the diagram. The 100 megabits per second technology is also known as a fast Ethernet. Two technologies that became important are the 100BASE-TX, which is copper ancillary to the pair, and the 100BASE-FX, which is a multi-mode optical fiber. The table shows you some of the important parameters and their values for this type of fiber or of Ethernet. 1000BASE-TX, uses a 4B/5B encoding, which is then scrambled and converted to a multi-level transmit 3 levels or MLT level. Again, the table here, the key things for you to find out here is what is a 4B/5B encoding system. The table gives you the pin numbers and the signals that are on those pin numbers. The 1000BASE-FX is a fiber version which is designed for backbone applications as well as connections between floors and buildings where copper is less desirable, and also for use in very noisy environments. Why do you then use fiber in noisy environments? The table here shows you some of the parameters, how it is used, so you can compare 100BASE-TX, 100BASE-FX, and 100BASE-TS and FX. So you can do a comparison and see how they work for the particular type of architecture, and the parameters are applicable. Let's now look at the 1000 megabits per second and the Gigabit Ethernet. The 1000 megabits per second Ethernet, or also known as the Gigabit Ethernet standards represent transmission using both fiber and copper media. The 1000BASE-X standard specifies a 1 gigabit full duplex over optical fiber, whilst the 1000BASE-T standard uses a media of category 5 or higher UTP cables. The 1000BASE-TX or 1000BASE-SX and 1000BASE-LX use the same timing parameters. 1000BASE-T standard is interoperable with 10BASE-T and 100BASE-TX. 1000BASE-T uses all the 4 pairs of wires instead of the traditional 2 pairs of wires that are used by a 10BASE-T and 100BASE-TX. This then provides up to 250 megabits per second pair with all 4 wire pairs, which provides the desired 1000 megabits per second. Recall that we said in this thing that we use the first 2 pins, right? And if each of them, now if you are going to use all the 4 pairs, then we can actually increase the transmission range. That is how it's done in the 1000, megabits per second Ethernet. The table there shows you some of the benefits of Gigabit Ethernet on fiber and compares that with other forms of the Ethernet. So you can look at that table and see the differences. Daisy chaining star and extended star topologies are also allowed. It is recommended that all links between a station and a hub or a switch be configured for auto negotiation to permit the highest common performance. Here we give you a table that shows you for various multimode fibers the modal bandwidth and the maximum distance that is permissible. 10 gigabit Ethernet is the latest generation and delivers a data rate of 10 gigabits per second. That is 10,000 megabits per second. And a fiber optic or twisted pair cable can be used. The 10 gigabit per second Ethernet is mainly used for backbones in high-end applications that require very high data rates. There are attempts to now introduce a 40, 80, or even 100 gigabits per second Ethernet. and research is seriously ongoing. The 10 gigabit Ethernet uses 2 separate encoding steps. The encoded data provides for synchronization, efficient usage of bandwidth, and improved signal-to-noise ratio characteristics. All 10 gigabit Ethernet varieties use optical fiber media. Where is the future of the Ethernet? Ethernet has gone through an evolution from legacy, fast to gigabit. And we are now talking about multi-gigabit technologies. The future of networking media is threefold. Copper, you can get up to 10,000 megabits, perhaps more. Wireless approaching 100 megabits, perhaps more, we can get. Optical fiber currently at 10,000 megabits, and soon to be more. We are expecting 40, 80, or even 100. But for those of us in developing nations where the cost of installation is a big issue, the idea is to think of how to increase wireless bandwidth to rates that make it very competitive and attractive. That brings us to the end of this session. Thank you very much.